Okay, so today we're going to be doing this question, and it just simply is about simplifying this whole expression right here at the top. So we're going to be using basic trigonometry rules, the ones you should be familiar with from early high school. But before we start, I want to go over the approach to answering this question. So there are a few things you must understand before you start tackling this question, and basically the rules and what everything in this expression here means. So first of all, you need to understand that this is an angle, and so is this, and this should make sense because the sine, cos, and tan operators only work on angles. So if this is an angle and that's an angle, it means it can be expressed in many ways, especially knowing that if this is an angle, it's talking mostly about a right angle triangle. And we're going to be using similar facts like ideas of sine of arcsine of let's say a ratio k is equals to k, and cos of arc cos of a ratio k is also equals to k. So if we find this angle and find that angle, you must also be aware that arc cos of this specific angle can be also expressed as arc sine, and that's how we're going to be answering the question today. And also this arc cos can be expressed as arc sine, such as this arc sine here could be expressed as arc sine, arc cos, and that one arc sine. So they can be used interchangeably. So I did say that these two are angles, and we can express them. They are angles of right angle triangles, and to start answering this question, we have to first see them as angles. So what we're going to do next is we're going to start drawing these angles, and we're going to see what they look like. So we're going to keep this a bit professional. We're going to draw both these triangles on the Cartesian plane. Yeah, I'm just going to have our Cartesian plane here, x, y, and we're gonna start now. I think we're gonna use a red pen. Makes sense. Okay, so first we're gonna start in with this specific angle. This is a right angle triangle, like I said. So we know that through SOHCAHTOA, you should know this, or better yet, just know how the whole thing works. So this is arc cos of √3/2. This tells us that this specific triangle has positive sides, a height of an adjacent, sorry, this is cos, so yeah, the adjacent side is going to be √3 and the hypotenuse is 2. So we're gonna just make this 3 and the hypotenuse is going to be 2. So this is not really to scale. I'm just gonna work on it assuming it's not to scale, and that's going to be 2. This is going to be √3, and this one we're just going to label as P. Okay, and then the next thing, and this is going to be our angle, we can just call it A for now. It's going to help us answer some of the more it's going to help us answer the question in general. Okay, that's our origin. So the next step would be to draw this triangle over here as well. This triangle has a negative opposite adjacent side. So this tells us that it's not on the first quadrant. For it to be negative, it has to be somewhere here on -3. And it has a hypotenuse of 5, and that's +5. So meaning that it should be somewhere up here, meaning that the opposite side here is going to be positive as well. So I'm just going to change that, make it a bit longer. And again, this is not to scale. I'm just trying to give a representation of these triangles, and then we're going to call this one B. So the length here is -3 and the hypotenuse is 5, and we're just going to call this Q. So this we can just call, I'm just going to erase that, And I'm gonna erase this as well. This is our angle A. Oh god, I did not want that. This is our angle A, and that's our angle B. So this is gonna come very important because we're gonna need to express this. We're gonna develop expressions for this angle A in terms of both arc cos and arc sine. So before we can do that, we have to solve for Q and for P. So I'm just gonna start solving for P here. It's just gonna be your obvious Pythagoras rules. Root 3 squared plus P squared is equals to 2 squared. And if you solve this out, you're gonna find that P is equals to 1. It should equals to 1. It's equals to 1 because we picked the positive square root, since the hypotenuse and that angle are positive. It's impossible for Q to be negative because it will be down here on the fourth quadrant, and it wouldn't make sense for the hypotenuse to be positive while Q is negative. That will be a bit impossible to draw. Okay, so next we're gonna find Q. So it's gonna be the same Pythagorean theorem. Q negative 3 squared, Q squared is equals to 5 squared. And here Q again has to be positive, if that wasn't obvious, and we're gonna find Q to be equals to 4. Okay, so now I'm just gonna attach these answers here. I'm gonna write it in, I think I'm gonna go for blue. P is equals to 1 and Q is equals to 5. So before we go ahead, I have to point out that we're gonna have to find expressions for these angles A, B, because so far we only have arc cos expressions. So it would be beneficial for us to have something other than arc cos expressions. So I'm just gonna use a green pen here. So A over here, already we know that A from the expression up here is arc cos. That's terrible. Arc cos of root 3 over 2. And okay, and that's it. And B is gonna be arc cos of negative 3 over 5. Okay, so now we want to express these angles as arc sine as well. Remember, arc sine is also gives you an angle, so we can express these angles A and B in terms of arc cos and arc sine. So the way we do that is we just use again, I don't know why I deleted that. Guess I can bring it back. SOHCAHTOA. Just gonna write it up here. Okay. So we're gonna use SOHCAHTOA to express this in terms of sine. So sine for A, it says its opposite over hypotenuse. This is our A. Opposite is 1 and hypotenuse is 2. So we can express this. I think okay, I was already using red. We're gonna use this as arc sine of 1 over 2. That's opposite over hypotenuse. And here we're gonna do the same thing with the other triangle, where we're gonna say the angle B is opposite 5. No, this is not supposed to be 5. Sorry about that. I made a complete mistake. Did I give it as blue? Yeah, that's gonna be 4. And here we're gonna go back to red. Okay, so it's gonna be 4 over 5. That's the opposite over the hypotenuse. And we have expressions for A and B. So now we're gonna use these expressions first, and then we're gonna try to simplify the question expression to something that will have no sines and arc coses and arc sines and whatnot. It's just gonna be made out of numbers because that's what they want it to be. Those who asked the question, anyways. Okay, so I'm just gonna write the question again here. It's you can give it in terms of blue. Yeah, sine of arc cos of root 3 over 2 plus arc sine, arc cos of minus 3 over 5. Okay, yeah, that looks very decent. Okay, so now we're going to use an identity that you should know from high school, and I'm just going to write it out here. It's the idea of sine A plus B is equals to sine A and cos B plus cos A multiplied by sine B. Okay, and we've already found expressions for our A and B. So what we have to do right now is when we've expanded this, we want to be able to use these rules over here, because these are very important. These are sort of simplifying rules. They make our lives easier, getting rid of trig functions without having to find or calculate them. It's basically a shortcut. So we're gonna use that to simplify our expression right now, because we have that. We're gonna plug this into that. Yeah, I think I can put it that way. And I think I'm gonna write it in blue, and I'm just gonna go back to blue. Makes sense. So it's gonna make our solution. I can write here. We're gonna have a solution. I'm gonna start saying this one expanded using this formula. We get sine of A, which is arc cos of root 3 over 2, and cos of B, which is arc cos of minus 3 over 5, and cos of arc cos. Yeah, it's a bit lengthy. And sine B, and sine B is arc cos. I'm running out of space here, and arc cos of minus 3 over 5. Just gonna put that. Okay, great. I was worried it wasn't gonna fit in there. Okay, so now we have this expression. We need to see what we can already simplify right now using the rules mentioned up here. So if we already have expressions that are in these two forms, that means we can already simplify it. So I'm just going to take out a red pen and see what we can simplify. So this one has sine and it has cos, so we cannot simplify this yet. We're going to have to change this angle into another form that will support that. This one is in terms of cos and arc cos, so this one can be simplified simply just by, will be left minus 3 over 5. This one can also be simplified because it has cos and arc cos. So this is already in the format we want it to be in. And this one cannot be simplified because it's sine and arc cos. We cannot just remove them. So we're going to change a few things here. I'm going to go back to blue. Sine of arc cos. Arc cos root 3 over 2 is A. And we found another expression for A in terms of arc sine. So arc cos of root 3 over 2 can be expressed as arc sine of 1.5. So I'm just going to specify that one here. Sine can be, and then we change arc cos into arc sine 1/2. Okay. And then this one, using our rules up here, cos of arc cos of k just gives us k. And that makes life a whole lot easier. We just left with minus 3 over 5. That's our k in this instance. And this one, again, it's the same as the previous one. We're going to be saying cos of arc cos of root 3 over 2. And we just left with root 3 over 2. And this one, we have to change arc cos into arc sine. So we're going to use the relationship we found for b in terms of arc sine to be arc sine of 4 over 5. So we're going to be having sine arcsine 4/5. This video has been going on for quite some time now. We're gonna have to simplify it. We have to finish it off now. Okay, and I'm gonna start using a red pen now because we're coming to the end of the question. So arcsine just becomes half, and then here we have minus 3/5. That's from that one, and plus √3/2. Just copy it down here. Doesn't need any rationalizing. Sine of arcsine is just gonna become 4/5. Okay, and we can just simplify this one. I think we're gonna have a common denominator, and we should have minus 3 if we multiply there over 10 plus 4√3 all over 10, and this gives us 4√3. We're just gonna write it a bit more neater and under one denominator, and that is our solution. And I hope that made some sense. Until next time.